Thanks, Seb. Yeah, so let's dive in, feet first, all the way, and talk about how the Arweave mechanism works. So today we're going to be talking about scaling Arweave and talking about scaling on-chain history from Bitcoin to Arweave. So we'll talk about the history of storing human history on blockchains. We'll talk about unlocking on-chain data and where we go from here. So human history has always been a part of blockchains, and to see how, we have to go back to the first block of the first decentralized blockchain, which is Bitcoin's Genesis block. Bitcoin's Genesis block had a single transaction in it, which is known as a Coinbase transaction. It's a special transaction that the protocol allows, and what it does is it awards the producer of the block with the block rewards. And in this case, it awarded Satoshi Nakamoto 50 BTC. Now, another special property of the Coinbase transaction, it allows the block producer to write 100 bytes or 100 characters of information to the blockchain. And in this case, Satoshi took the opportunity to write the following quote: "The Times, 3rd of January, 2009, Chancellor on the brink of second bailout for banks." And in doing so, he wrote or inscribed human history into the very first block of the very first blockchain. So this is going to be a bit tricky because I noticed that the animations aren't playing on these slides, but we'll do our best. So Bitcoin launched in January 3rd, 2009, and it proceeded to get a number of updates and improvements, and even Satoshi himself stepped back from the protocol during this time, up until about 2015, where a conflict started brewing within the Bitcoin community. And half of the community wanted to increase the block size and allow there to be more transactions in Bitcoin. And the other half of the community wanted to keep it small and preserve the decentralized properties of the network. And this stalled all development on Bitcoin for about 2 years, called the block size wars. And it ended with the big blockers splitting off and creating a new chain called Bitcoin Cash, and the existing mainline of Bitcoin continuing on with a soft fork called SegWit. So what did SegWit do? Well, you can see here on the left, we have before SegWit, and Bitcoin blocks had their Coinbase transaction, and then a number of transactions moving tokens from one address to another, and their signatures. And after SegWit, and somehow they did this with a soft fork, which meant it was backwards compatible with like existing mining software, which I don't know how they did. Some sort of magic there. But it moved all of the transactions to the top of the block, and it increased the overall block size while still limiting the transaction portion to 1 megabyte, sort of preserving the original intent of the protocol. But what it did is the signature data and metadata was moved into the witness data, and this increased the amount of information that Bitcoin could store that wasn't purely transaction data. This ultimately led to some pretty interesting things down the road, where you could start to see these sort of very compressed images being added to the witness data of the Bitcoin blockchain. But going back, so back to 2017, a PhD student by the name of Sam Williams is reading some very depressing books, like Gulag Archipelago in 1984, and he works himself up into a frenzy and decides to create a blockchain to permanently preserve the world's knowledge. He was reading these books about how authoritarian regimes manipulate their society by manipulating history. And so Sam put together a team sometime in 2017, and a year later, Arweave's mainnet was launched. And if you thought I was kidding about the depressing books, it was launched on June 8th, 2018, which was the 39th anniversary of the publishing of George Orwell's 1984. Now, Arweave had some impressive stats when it launched. It had 1,000 transactions per block. It had 2-minute block times, and each transaction could be 5.8 megabytes in size. That means a single Arweave transaction could store an entire Bitcoin block, witness data and transaction data together. And so just like Bitcoin, Arweave progressed to had updates and improvements over the next couple years until March of 2020, at which point Arweave unlocked very large transactions, let's call them. The maximum transaction size became 2 to the 256 power minus 1, which is a limit. It is limited, but it's limited to like the number of atoms in the known universe. So from a protocol standpoint, it's very large transactions. There is a practical limit, though. The amount of data that miners are providing to the network and the amount of bandwidth that exists does actually constrain the size. But from a protocol standpoint, it's scaled to very large transactions. So how did they do it? Yeah. So this is where it's going to get tricky without the animations. So to understand how Arweave did it, there's two different mechanisms, security mechanisms that we want to look at. One is consensus, and this is a mechanism where all the participants in the network, all of the participants in the protocol need to come to agreement on what the current state of the protocol is. And the other type of mechanism is a mining mechanism. And this is traditionally something that just individual miners perform, a work that they perform, famously on Bitcoin is proof of work, just to be able to participate in the network. And so we can see here for Bitcoin, the consensus mechanism is longest chain, which is how the participants in the network come to agreement on what the current state and witness data is for a Bitcoin block. And then famously, the mining mechanism is proof of work, where they calculate a lot of SHA-256 hashes. So this is an example of longest chain. Occasionally, because of the randomness in mining, their two blocks can be produced at the same time. And at this point, the network, the participants in the network need to decide which one to use. And the way they decide that is by waiting for one of the chains to become longer than the other, and then using that as the official state of the network. What's really interesting, so we have our Bitcoin blocks here. They have their little Coinbase transactions. You can see the transaction data, the gray block on top, and then the witness data, the blue at the bottom. And there's all around 4 megabytes in size. What happens on Bitcoin is, you can kind of see it moving away here. But once the node, the miner, has used the witness data to verify the transactions, they can just throw it away. There's no reason for them to keep it beyond the very first time that they process a block. And that's by design. That's to keep the system requirements for operating a node low. So there can be a lot of nodes on Arweave or on Bitcoin. But Arweave fixes this. For a protocol that wants to store the human, all of the world's knowledge, it needs to have stronger incentives to store data. Right. So how does Arweave fix this? What changes? So one of the key innovations that Arweave did was it changed the mining mechanism. Instead of just blind hashes, Arweave uses something called Spora, which is succinct proof of random access. It's a cryptographic proof that the miners do to prove that they're storing small chunks of Arweave's data, 256 kilobytes at a time. And what this did is it allowed the protocol to move the security from the data, from the consensus mechanism that required everyone in the network to have it to come to agreement, to the mining mechanism, which meant miners could all individually prove that they were storing data, which greatly improved. Yes. Okay. Is there any way that we can get the animated version of these slides? Because this is going to be very difficult to explain without it. So I'll keep talking through it. So here's an example of Arweave blocks, and you can see that the data portion of the blocks varies in size. Every block on Arweave can store different amounts of data, and what the Arweave protocol does is every second the protocol ticks, it gives a new range for miners to mine. So that's what these little blue rectangles are in the data portion. Every second there's a new range of data for it to check for proofs. And occasionally, like we're seeing here, there's a little pink block. That is a proof that allows the miner to produce a new block. And when the miner gets a winning proof, it makes a new block. And it earns block rewards. So you can sort of see that there. The issue there, or not the issue, but the interesting thing to note is that the network came to consensus about the transactions, but the data isn't there yet, which is a little bit surprising. So you can see it's a gray box. And so what happens over time is, as mining continues, the data starts to stream in from different areas of the network. And with each step, with each new block that's produced, the miner trades with other miners to get that data and fill it all in. And you can see that the mining mechanism on Arweave starts to allow the miner to generate proofs from that new data as it comes in. So as blocks are added, you can see we're at the third block is added now, and the miner is able to like fully mine that data. And as the new blocks are added, you can see the data starting to stream in on them as well. And what this does is it incentivizes miners to trade data with one another. They all want the new data because it allows them to perform more proofs and have a better chance of earning rewards. And so what happens is the data added to Arweave gets replicated all around the network hundreds of times because of the mining mechanism. So this is how Arweave unlocks on-chain data at any scale. It also incentivizes the replication of data, and it makes Arweave data and transactions censorship resistant. So you might say, well, DMac, I've used Arweave before. I just post the transaction and it goes. I don't know what you're talking about separating the transaction data and stuff like that. Well, the reality it is you probably posted your transaction to a gateway like arweave.net. And it did, under the covers as a convenience for you, it did this for you. It posted the transaction to a new block, and once it was mined, it sent the data along to all the miners in the network, which is great. But it also introduces the opportunity for censorship. Say the gateway didn't like the transaction. It saw something in your data and it's like, I don't want to post this. It could just throw it out. But if that was the whole story, I'll go back because this side's a little easier to see. If that was the whole story, then Arweave would have a centralized gatekeeper to its protocol, and it wouldn't be completely decentralized. But the good news is Arweave is. And you can skip the gateway. You don't have to use it. You can just post your transactions directly to the network, and once they're included in a block, you can add the data, and it'll be replicated around the network. So this is really important because it keeps gateways and services built on top of Arweave honest. So Arweave development continued. And a month after the large transactions were introduced, Arweave rolled out ANS 102 bundles. Apologies for the layout here. And what bundles did, it has allowed these very large transactions to include many other transactions. And so Arweave started to scale in two dimensions: large transactions, and large volumes of transactions. This was useful, but it wasn't until a year later when ANS 104 came out, and this optimized the ANS 102 standard, improving the performance of bundles, their space efficiency, and the compute required to create them. And this resulted in a huge unlock for the protocol. ANS 104 bundles launched around the same time as NFT Summer on Solana, and people were uploading massive collections of like 10,000 NFTs and using bundles to do it. And you can see just the growth of Arweave's data set since then. So that brings us up to today. We are maybe, I would say, weeks away from the 2.7 upgrade to Arweave. And again, it's going to include optimizations for bundles. They're going to be even less computationally expensive to produce. And it also introduces the same censorship-resistant mechanism that block transactions have will now be available in bundles as well. So I think the point that I want to make here is that Arweave, the data model on Arweave has been stable for the last 3 years. Since the introduction of bundles and large transactions, the types of updates that we've seen to Arweave have all been around improving the performance, the censorship resistance, and ultimately the decentralization of the protocol. So in review, recording human history has been part of blockchain since the beginning, but that frontier has really moved from Bitcoin to Arweave at this point with its scalable on-chain data. And then with bundles and large transactions, since April of 2020 last year, Arweave has been able to scale in multiple dimensions to be the ultimate location for on-chain data. And going forward, I expect to see more of the same with incremental updates to the performance and decentralization of Arweave. So that's me. I'm DMac. You can follow me, DMac on Arweave, on Substack or on the site formerly known as X, or Twitter, now known as X. And that's it. Thank you very much.